this is net force. Let me go ahead and solve this real quick. So I'm going to start off with these ones. So, oh, I forgot to add this. This was supposed to say 9 newtons down here. Okay, so anyhow, I'm going to start off with these ones. 3 plus 3 plus 3 equals 9 newtons. All right, and 9 minus 9 equals 0 newtons. So these cancel out. Goodbye. All right, now you're going to add these over here. 6 plus 1 plus 8 equals 15 newtons. All right, and 15 minus 10 equals 5 newtons. And since this side is bigger, than this side, then, it's going to be going to the right, or excuse me, to the left. So it's going to be 5, let me just put my answer big, 5 newtons to the left, Okay. Now, next, it says using the total net force that you found from the problem above, how fast is the block accelerating if it has a mass of 34 kilograms? And don't forget to use the correct units. Big deal, guys. So we know what the force is. We know what the mass is. We do not know what the A is. And that's not the actual formula, so let me not do that. So we don't know what A equals. There we go. So we're going to be using this formula. A equals F over M. All right, so F is 5 newtons. And M is the 34 kilograms. And then if you divide that, you end up with 0.14 something. You can even round it to 0.15 if you want. And you can either write newtons over kilograms, or you can write meters per second square. Okay? Either of these are good. Next. Okay. So now, that's pretty bright. So now I've got, it says, what are action-reaction forces taking place in the situation? You slam your hand on the desk. So action, slam, hand on desk. Okay, and the reaction is desk pushes on hand. It's just that simple. Okay, force diagram. Draw a diagram for the following. A book is falling through the air. So if a book is falling, it's going down. Okay, so I'm going to draw my force diagram. Obvious one is gravity. Okay, force of gravity. And then, there is a normal force, but it's not very big, obviously, if the book is going down. And there definitely is air resistance because it's moving through air. And then if you really want, there definitely is friction too, because air, if it moves through air, is causing friction. But none of these are big enough to overpower this one. All right? So that's what that looks like. Okay. That's all for assessment number 13, I guess.